Alright, so here's a tricky problem that involves how a capacitor charges over time. Yeah, so what is the time constant? That's just the resistance times the capacitance. So here we are looking at the time constant. This is the Greek letter tau. Think, like Greek T for time. And to find that, we just multiply resistance times capacitance, and we use SI units, so I put this from millifarads to farads, and we get 3.02 seconds. And that is the time it takes for the capacitor to get about 63% charged. Now, we have to find out how charged that capacitor is after 1.15 time constants. And here is the general equation for finding the charge after some time t. And note that t is divided by the time constant. So the thing is, if we know that the time we're looking at is 1.15 time constants, we can just put 1.15 RC in for our time, and that is handy because we can cancel the RCs, and that gives us an equation where we just have numbers we can plug in. E is the number E, the number E, the little E on your calculator. And I guess we do have to figure out what is the full charge value. What would be the full charge after a long time? That's the Q naught. And to figure that out, we just have to remember this equation for capacitance. It's the charge per the voltage, and rearrange it for charge. Plug in our numbers in SI units and get this many coulombs. And we plug that in there. Oh, and here it is. And our answer for that charge after 1.15 time constants makes sense because it's we'd expect it, if it was exactly after one time constant worth of time, we'd expect it to be 63% charged, but this is a little bit more. I want to talk about an alternate way to approach the math here for you guys who like numbers more than letters. We found the time constant RC is 3.02, right? So really it's e to the negative 1.15 3.02s over 3.02, which there you have 3.02 canceling. Same thing, just another way to think about it. Oh, and the last thing is, what would the charge be after a long time? That would just be its full charge that we already calculated over here. This is technically this is Q naught, and I just rounded it a little bit.